In this demo, we'll look into compression. Our API supports this out of the box. This improves performance as well, as we need less bandwidth. Let's try and get a compressed version of a poster. We already know how to get a poster because we wrote our getPosterWithStream method previously. So let's copy this. And let me paste that in. And let's rename this to getPosterWithGzipCompression. We can also clean up this method a bit. We don't need this commented out code anymore. gzip is one of the compression formats supported by our API. Other formats, like deflate, exist as well. If you're integrating with an API, check the documentation to see which forms of compression are supported. We know from previous demos that we can use the accept header to ask for a specific format. Well, there's another header, accept encoding. That can be used to ask for a specific encoding, if the API supports it. And that's what we're going to use now. We only want to accept responses that are compressed in the gzip format. To do that, we add a new string value to the accept encoding header. That should be sufficient to ensure we get back a compressed poster. Let's put a breakpoint here, and let's ensure we call getPosterWithGzipCompression. Let's give that a try. And it seems like we don't even hit our breakpoint. We get an error when reading out a response. An unexpected character was encountered while parsing it. Well, this isn't that unexpected. We're now dealing with a compressed response. So far so good. Our accept encoding header had the effect we wanted. But we do still have to decode the response. Let's go back to our code. The HTTP client handler HTTP client uses by default supports decompression out of the box. But it isn't enabled out of the box. To enable this, we instantiate our HTTP client with a new HTTP client handler on which we set automatic decompression to system.net.decompressionmethods.gzip. We learned about handlers in the first module, but this is the first time we're actually instantiating one. You can already see that with handlers we can easily add functionality to our client. Later on in the course, there's a full module on using handlers. For now, this is sufficient. Let's give this a try. This time we do hit our breakpoint, and we get back a decompressed poster. So we've just improved performance with compression thanks to lower bandwidth use. Note that the other code will still work as well. The handler will only try to decompress when the content is actually compressed. It knows this by looking at the content encoding header of the response. Let's have a look at the module summary. Streams are the preferred way of interacting with an API through HTTP client. Main drivers behind this choice are the reduced memory footprint and, due to that, performance benefits. We can use streams in different parts of our request-response cycle. When receiving a response, we can stream that from the response's HTTP content into an object, thus passing by the requirement for an in-memory string copy of that content. To ensure that we can start streaming as fast as possible, we should set the HTTP completion mode to response headers read. This allows us to start reading into the stream once response headers have arrived. When we send our data, we can use a stream as well. By doing so, the request body content gets created without an in-between string copy of the object we want to send. Lastly, we can enable compression. By doing so, the data that's sent over the wire is smaller, which results in less bandwidth consumption and thus faster performance. If an API supports compression, it's sufficient to set the accept encoding header to the compression format we want to accept and to enable automatic decompression. Imagine sending a request from an application page to download a large file. The user might get tired of waiting and might navigate away. In that case, and in other cases, we want to cancel that request. In the next module, we'll learn why and how. It's often overlooked, but cancelling requests can be beneficial to performance, both at level of bandwidth consumption and scalability. Let's learn how. I'm Kevin, and I'll guide you through this. We'll start by learning why we should cancel requests when we no longer need them, say when loading a large movie trailer. We'll learn how we can cancel a request, and we'll learn how we can handle a cancelled request. Let's dive in. Imagine we're using HTTP client to get a movie trailer. Chances are that the user of your application will navigate away or press a cancel download button. In such a case, you want to be able to handle that instead of just letting the request continue. The reasoning behind this is based on the fact that behind the scenes, HTTP client works with async tasks. If you're interested, I've got a full course on using async when building an API with ASP.NET Core that goes into a lot of detail on those tasks and asynchronicity. But for our purposes, it's important to know that cancelling a task that's no longer needed will free up the thread that's used to run the task. And that means that that thread is potentially returned to the thread pool where it can be used for other work. This thus improves the scalability of our application. So this is one use case we have to cover. In this case, we are cancelling the task. There's another reason though. It's not unheard of for a timeout to happen. If that happens, we want to be notified of that so we can gracefully handle such a timeout. In such a case, it's due to the timeout that the task gets cancelled. But we still need to be able to gracefully handle it. Both cases are true for all types of resources. Even when getting one movie, a user might navigate away or experience a timeout. To support cancellation of async tasks, a cancellation token source and a cancellation token are used. A cancellation token source is an object which manages and sends cancellation notifications to the individual cancellation tokens. It exposes such a cancellation token via its token property. And such a cancellation token is what we need to pass to be able to listen to cancellation requests. To make this a bit more tangible, let's go back to our movie trailer example. If we want to cancel the downloading of the movie trailer whenever a user navigates away or for whatever other reason, we need to be able to pass a token to our HTTP client sendAsync method. When we call cancel on the cancellation token source the token is related to, our HTTP client object will be notified of this. That doesn't mean the download is cancelled then. It's HTTP client that takes care of this. So HTTP client listens for cancellation and then effectively cancels the request. Let's have a look at a demo. In this demo, we'll learn how we can cancel a request. We're looking at a bare bones cancellation service. Nothing new here, it's just a service we'll use for the demos in this module. Let's add a static HTTP client field and initialize it. So we add a using statement to system.net.http and we initialize the HTTP client with an HTTP client handler that has automatic decompression set to gzip. That's how we ended the last module. In the cancellation service constructor, we set some defaults. Nothing new there. Let's scroll down a bit and let's add a new method. We'll name this method getTrailer and cancel. So in this method, we're going to send the GET request to get a trailer, and then we're going to cancel it using a cancellation token source and a cancellation token. First, we create our request. That's GET request to movies / a movie ID, trailers / a random GUID, as trailers are randomly generated sets of bytes. We set the accept header to application JSON, and for that we import system.net.http.headers. We set the accept encoding header to gzip, so we can use gzip compression. Lastly, we send our request using the best practices we learned in the last module. To read and deserialize the stream, we call read and deserialize from JSON on our stream. That's an extension method from Marvin.stream extensions. Trailer is defined in our models namespace, so we also need to add a using statement to movies.client.models. And that's it for the getTrailer and cancel method. Or at least, that's it before we add cancellation. We just learned that to support cancellation, we need a new cancellation token source. So let's instantiate one. Cancellation token source is defined in system.threading. So let's add a using statement by pressing enter. From this source we can pass through the token when we send a request. Like this, HTTP client can listen to cancellation. To pass through that token, we use one of the sendAsync method overloads. We can access the cancellation token via cancellation token source.token. Lastly, we need to actually cancel the request. As we learned, you'd typically do this when the user navigates away or presses a cancel download button. On cancellation token source, there's two methods we can use to effectively send a request for cancellation. Cancel will immediately ask for cancellation, while cancel after will do so after a specified amount of time. For the demo, we'll use that one. We'll cancel after 2 seconds. So we call into cancel after and pass through 2000 milliseconds. Alright, that's it for this method. Let's make sure the getTrailer and cancel method is executed. So in the run action, we add an await getTrailer and cancel statement. And then let's open the program class, because we still need to make sure that the cancellation service is used instead of the stream service from previous demos. For that, let's uncomment the registration of that. Alright, let's give this a try. And we hit an exception. But it looks like a good exception to hit. It's a task cancelled exception. And this is what HTTP client throws when it has cancelled the request. So this is what we want. So far, so good. But is this a good place for initializing the cancellation token source? Let's have a look in the next demo. Let's look back at our code. We are instantiating the cancellation token source in the scope of our method. That's good for demo purposes, but typically you want to be able to pass the token to different concurrent requests to allow cancelling all of them in one go. Next to that, you often want to access that cancellation token source instance from other parts of your application. For example, to cancel when the user navigates away or presses a cancel download button. So to make this more realistic, let's put the initialization of the cancellation token source outside of the method and have the method accept the token. So let's comment this out. And let's add a new private field to our cancellation service. We name the field cancellation token source and we initialize it. In our getTrailer and cancel method, we then accept a cancellation token. It's this cancellation token that we pass through to our sendAsync method. Lastly, in the run method, we pass through the token and we ensure we cancel after 2 seconds. Alright, let's give this another try. And there we go, works as expected. We still need to handle the exception that happens on cancellation though. Let's have a look at the next demo for that.